Okay, so
Hmm.
let's get stuck into this. We hear so much about what AI can do, its power, right, the potential.
Yeah.
But what if the way it learns actually builds in these, well, fundamental blind spots?
Right.
We're talking about things AI might just not be able to predict or even understand because, they're completely outside its experience. These unexpected events people call black swans.
Hmm.
And maybe more worryingly, how small errors can apparently build up into, well, one source had a pretty memorable phrase for it, the snowball of shit.
Yeah, it's blend, but it gets the point across. And that's exactly what we're digging into today, these inherent limits in AI, particularly when it faces the unpredictable. You send over a great stack of sources that really explore this, focusing on AI as an inductive system.
Right, and the consequences of that structure. It seems like these pieces aren't just saying AI has limits, end of story.
Yeah.
They're trying to unpack why it struggles with the unknown, the potential risks involved.
And crucially, what kind of attitude we need when using these tools. Tools that are incredibly powerful, yes, but also fundamentally imperfect.
It's less about the cool stuff it can do and more about the foundations, maybe.
Exactly, the underlying architecture.
So where do the sources say this core limitation actually comes from? It sounds like it's baked right into the learning process itself, this idea of inductive reasoning. What does that mean for AI, practically speaking?
Well, at its heart, inductive reasoning is just learning by generalizing from examples. You see lots of specific instances and you draw a general rule. AI systems, they do this on a massive scale. They're fed, just vast amounts of data, millions, billions of points.
Okay.
And they spot patterns in that data. Then they build models based only on those observed patterns to predict things or understand new inputs. Think of the classic example they always use.
The swans.
The swans, exactly. If all you've ever seen your whole life are white swans, thousands, maybe millions of them, you inductively conclude all swans are white, your internal model gets really, really good at identifying white swans.
Right. It predicts white for the next swan with extremely high confidence based on all that data.
Precisely. Your system is robust for white swans, and then, bam, a black one shows up.
The black swan, the thing that just wasn't in the training data at all.
That's it. It's the unexpected event. Because the AI's entire model of swanness was built solely on white swan data, it has absolutely no framework, zero experience to predict it, understand it, or react appropriately. It's literally outside its learned reality.
And this is where it gets tricky. According to the sources, they say the AI might even be able to explain the concept of this limitation. Like, it could define inductive reasoning limits or out-of-distribution data.
Yes, theoretically it understands. It can define the black swan problem, but, and this is the critical point these sources hammer home, when it's actually confronted with a real-world situation that is a black swan for its specific training, it often just doesn't recognize it.
It doesn't see this specific thing as an instance of its own limits being tested.
Exactly. There's no internal alarm bell going off saying, hold on, this data doesn't fit, my knowledge is insufficient right now. It lacks that sort of situational awareness of its own boundaries.
So instead of flagging uncertainty, instead of saying, I don't have data on this, it might just confidently give an answer based on its limited white swan view of the world.
That's the danger. It generates a response using the only model it has, even if that model is completely inadequate for the new black swan situation. It doesn't possess the lived experience or context to realize in that moment that it doesn't know.
That gap between knowing the theory of limits and recognizing them in practice feels really key. What is it about the AI structure, then, that makes this kind of real-time self-awareness so difficult?
The sources point to a couple of fundamental things. First, its reliance on fixed training data. The AI's core knowledge, its world model, is essentially a static snapshot taken at the time it was trained.
Like a photograph of the world at one moment.
Sort of. One source uses a good analogy. Sampling seawater. You can take a huge sample, terabytes of data about the water's composition, temperature, salinity right then, but it's still just that single sample, a snapshot from one specific point in time and space. It's not the whole dynamic ocean.
So anything new that happens after that snapshot, a new trend, a sudden event, our black swan isn't part of the AI's foundational learning.
Exactly. And that ties into the second point. These systems are generally passive, open-loop systems. They don't typically interact with the real world in a way that provides constant feedback to dynamically update their core learning models based on new experiences.
So things like deep search or plugins can pull in current facts, but they don't fundamentally change how the AI learned its core understanding. It's like an add-on layer.
Often, yes. It adds information, but doesn't restructure the underlying model learned from the initial static data. It's not learning from interaction in the same way a person might. It hasn't lived through 2023 and adjusted its core understanding based on those events if its training data stopped in 2022.
Okay, I think I get that. It can access recent info, but hasn't internalized it through experience in the same way?
Right. And this leads back to the third point, what sources call superficial limit awareness. Because it's operating from that fixed sample and isn't constantly learning from dynamic interaction, its grasp of its own limitations stays theoretical. It knows limits exist in principle.
But encountering a genuinely new, unexpected black swan event out in the wild doesn't reliably make it go, wait, my internal map doesn't cover this territory.
Not reliably, no. It lacks that robust mechanism to connect the theoretical knowledge of limits to the specific, messy, real-world situation unfolding right now.
Okay, so if it has this sort of theoretical awareness, but doesn't recognize its limits when they actually matter, what happens? This must be where that very vivid metaphor comes in again, the snowball.
The snowball of shit, yeah. It's graphic, but it explains the risk well. Because the AI doesn't recognize it's hit its limit when facing the black swan, because it doesn't flag that initial interpretation as flawed or based on incomplete data its next steps.
It's subsequent reasoning.
Exactly. Any further conclusions, generated text, or actions are built on top of that initial, unrecognized error.
Ah, so it just keeps rolling, picking up more errors as it goes.
Precisely. The errors compound. They accumulate and amplify. A seemingly minor misstep or omission when first encountering the black swan can lead to layers upon layers of faulty logic or incorrect output. It can grow quite dramatically.
And the sources seem pretty concerned about the potential consequences, warning about serious, maybe even irreversible damage. That definitely raises the stakes.
It really does. They stress that because these errors can cascade silently, built on that flawed foundation, the results aren't just minor glitches. Depending on how the AI is being used, this could ripple through connected systems, influence critical decisions.
Leading to real-world harm.
Yes, potentially significant and in some cases irreversible harm. It impacts not just the AI or the immediate user, but maybe other people, other systems, the wider environment. And this is where the sources push back hard against any idea of omniscient intelligence, human or AI.
The idea that perfect judgment is possible from limited information.
Exactly. They argue that believing you can have perfect judgment based only on sampled, historical knowledge is inherently dangerous. That belief itself becomes a risk factor.
Wow, okay. That's sobering. So, if we can't actually stop black swans from happening, and we know inductive systems will struggle with them, potentially leading to the snowball effect, how do the sources suggest we even deal with this? Are there solutions?
Well, they're very clear these are partial solutions, ways to manage the risk, not eliminate it entirely. One approach is simply building AI systems to be more upfront about their limits.
Like programming them to say, I don't know?
Essentially, yes. Providing concise answers, but also explicitly stating when a query falls outside their training data or known operational range. Something like, based on my training data up to date, I cannot reliably predict this. Or, this scenario is significantly different from my training examples.
So transparency about the boundaries.
Exactly. They also mention, the potential for future AI architectures to maybe incorporate more closed-loop learning, more dynamic adaptation, but that's not the fundamental nature of most large models right now.
More of a research direction than a current reality for many systems.
Right. And then there's the absolutely crucial role of human oversight.
Ah, the human element. Providing the context, the judgment calls.
The common sense, the ethical considerations, the creative problem solving that the AI stuck in its data patterns just lacks. It's about humans actively supplementing the AI's inherent limitations.
Makes sense.
And the sources also really want us to rethink what trusting an AI means. They argue it's not about believing the AI delivers absolute truth.
So what is it then?
It's more about understanding its predictable performance within known conditions, knowing its likely accuracy, its error margin, when it's operating inside the boundaries of its training data.
Like trusting a scientific instrument to be accurate within its specified calibration range, but not expecting it to measure something completely outside that range.
That's a good way to think about it. It's a statistical understanding based on performance on the sample data, not a guarantee of truth when faced with the truly unknown or the infinite complexity of reality. One source used a great analogy here about reading books.
Oh, yeah.
Reading, say, 1 million books, a huge quantity of data, and doesn't automatically give you the truth about the world if the content of those books, the sample distribution P, is biased, incomplete, or just doesn't reflect the part of reality you're suddenly facing.
So just feeding the AI even more data doesn't solve the black swan problem if that new data still doesn't happen to contain that specific unpredictable event. Quantity doesn't fix the sampling issue.
Not fundamentally, no. If the sample, however huge, still excludes that specific black swan possibility by its nature, the AI remains blind to it. So the core takeaway from these sources is, since black swans are, by definition, unpredictable, an inductive AI system cannot fully handle them in advance. Therefore, the focus has to shift. It can't just be about trying to prevent the unpredictable from ever happening to the AI. It must be about managing the potential errors and the fallout when, inevitably, the unpredictable does occur.
Okay, that makes sense. Manage the impact, not prevent the unpredictable itself.
Yeah.
Which seems to lead straight into what the sources say about the attitude we need when we work with these systems. They suggest it's something more than just intellectual humility.
Yes, they really push beyond just saying, be humble. They argue for something more direct,
Ah,
more proactive, a willingness to squarely face the genuine possibility of errors and to acknowledge that these errors can cause real significant, maybe even irreversible harm.
so it's not just a polite, oh, models aren't perfect. It's a much more grounded recognition that imperfection here can have serious consequences.
Exactly. It's an attitude born from acknowledging or perhaps even experiencing the potential damage. It's pragmatic carefulness driven by understanding the real risks involved. And they link this attitude to concrete actions and behaviors.
Like what?
Well, things like genuine epistemic humility, truly internalizing that our models, our data, are not the same as absolute truth. They're just representations, limited ones.
Yeah.
Also, continuous auditing, not just assuming things are working, but actively building processes to constantly look for errors, acknowledge them, learn from them, not sweeping small anomalies under the rug because they might be signals of a bigger issue.
That sounds important. What else?
Diversity of perspective, recognizing that any single viewpoint, any single data set, including the AI's, is inherently limited, seeking multiple angles, and, crucially, valuing human judgment.
Coming back to the human role again.
Absolutely. Understanding that humans are essential for interpreting context, applying wisdom, making complex judgment calls, especially when things get ambiguous or unprecedented, precisely where AI tends to hit its limits.
Because at the end of the day, these AI systems, these data tools, they're incomplete tools, as the sources put it, not magic solvers.
Exactly. They're powerful aids, but fundamentally limited. And any steps we take to mitigate the risks, better transparency, auditing, human oversight are necessary. But they remain partial solutions to this core challenge of inductive learning facing an infinite, unpredictable reality.
Right. So just to wrap up this deep dive then, we've really unpacked how AI's core learning method, inductive reasoning from fixed data, makes it inherently vulnerable to these black swans, these completely unexpected events outside its training.
hmm And we saw how, because it often lacks that crucial self-awareness to know when it's operating outside its reliable knowledge base, initial errors can compound, creating that potential snowball of shit with risks of significant, sometimes irreversible damage.
Yeah, and we looked at the underlying reasons, the static data snapshot, the passive system design, the gap between theoretical and practical limit awareness, and crucially, while we can manage these risks somewhat,
Through things like clear communication of limits, robust auditing, and indispensable human oversight.
a complete fix for handling the truly unpredictable within this kind of inductive system just doesn't seem to be on the table right now.
And the really vital takeaway echoing through these sources is the attitude required. It's more than just abstract humility. It's a very practical, clear-eyed stance.
Actively confronting the possibility of error, understanding the potential for real harm, and using these incredibly powerful tools with a constant awareness of their fundamental limitations.
Exactly. Using them wisely means understanding where they break.
It really makes you wonder, doesn't it? If
Mhm.
any knowledge system, whether it's sophisticated AI or just our own human brains, has to rely on finite experience, on samples of reality, to try and make sense of an infinitely complex and ever-changing world. What does this whole analysis of AI's black swan problem really tell us about the fundamental limits of all knowledge, human knowledge included, and maybe about the constant, perhaps unavoidable risk of the unpredictable that we all live with, no matter how much data we gather or how much we think we know? Something to chew on, definitely.